So my name is Eddie Felmer. There's a couple of faces I know from customers, so thanks very much to Net-Ctrl. So I've Connor here from Net-Ctrl and Mark also, and a customer, but yes, so thanks very much for inviting me along to talk about Wi-Fi 6, aka 11 or .11ax. So I'll talk about where that comes from for those that aren't familiar, but this is really your chance to learn everything you didn't know about Wi-Fi 6. Unless, of course, you know more than I do, in which case maybe you want to come up here and do it instead. Any volunteers? I guess the other thing, very quiet you lot, aren't you? The other thing I can say is that this is probably about, well, the holiest I've ever felt to be in a chapel and addressing an audience. A congregation there, a flock at the back. Thank you. Yeah, they're paying attention now. Might have you up front in a minute. Right, so to carry on, so yeah, so I'm from Ruckus Networks, so note the networks part for those. How many Ruckus customers have we got here then? Big cheer. Oh, look at that, that's pretty good actually. Right, have you got their names? Yeah, right, just to make sure if they're different partners. No, so that's a good turnout for Ruckus, but of course we are Ruckus Networks, so I'm not allowed to pitch about our products or anything, of course, or our technologies, but just as a quick overview. You know, from the Brocade acquisition, we also have now a range of switches, ICX switches, hence it's not Ruckus Wireless, it's Ruckus Networks now, as we do switches and wireless. And they work very well together with our Smart Zone. You can now manage them all together. So really, just at the start here, so you know, Wi-Fi 6, so who's heard of Wi-Fi 6? So quite a few nods there. And do you know why it's called Wi-Fi 6? Anyone want to? That's right, yeah. So the name actually comes from the Wi-Fi line. So I'll talk a little bit about the two bodies that are responsible for looking after, you know, Wi-Fi and wireless, the IEEE and the wireless, the WFA, and where that comes from. But really what they've wanted to do is to make it simpler for people to identify, instead of using the sort of a technical name for it like .11ax, .ac and so on. They wanted to make it simpler for people that are actually using wireless networks or Wi-Fi networks to identify what sort of network they're on. So just like when you're using your cell phone and you're on a 3G network or a 4G network and soon to be 5G, then you know, you'll actually get a symbol very similar to this. I don't know, have I got a pointy thing on here somewhere?
Yes, there's a top bottom.
Oh, there you go. So a little symbol like this, you'll go. And this, the 6 means that it's Wi-Fi 6, which is 11ax. 11AC that you're probably familiar with, so that is Wi-Fi 5, 11N is Wi-Fi 4 and so on, going back to the older days. So it's just about making it easy to identify rather than people referring to it in the sort of the IEEE technical way. So some of the questions I'm looking to answer, so I'm looking to answer what is different, what's the evolution of the 11ax or Wi-Fi 6 compared to 11AC and the previous technologies. Why you might want to use it and where you use it and what it's actually doing for you, so where you use it as well, and about the two bodies, so the IEEE and the Wi-Fi Alliance and what their parts in this are as well. So predominantly what Wi-Fi 6 is about, it's about capacity. So I'll talk a little bit about performance and so on, but what it's really about is reliable capacity. So it's known as high efficiency, and that's because a lot of the things that have gone into Wi-Fi 6 are all about making it much more efficient, and also to play better in congested RF environments. So in terms of why, it is predominantly about high density deployment. So it is about addressing the need of ultra high density deployment. So in education, some schools obviously do have you know, high density depending on classroom sizes, depending on the deployment. You may have you know, single AP serving 2 classrooms, for example, that actually have got 30 plus devices in each, so that's reasonably high density. But really it's dealing with ultra high density is its target market, and that is to be working in sort of public deployments, so train stations, stadiums and so on. That's really where Wi-Fi 6 is predominantly aimed at. So what you'll actually see as new access points come out that are Wi-Fi 6 capable is that they're typically aiming at the premium mid-range to premium sort of range, rather than starting at the lower end, sort of 2 streams and so on. So you know, they're targeted at much higher densities than you might typically see in most parts of the school. Unlike 11AC, Wi-Fi 6 or 11ax is also a technology that's available to use on both 2.4 and the 5 gigahertz band. So AC was predominantly targeted at improvements, enhancements just in the 5 gigahertz band. So a lot of the features and techniques for increasing the capacity and the speed and performance of Wi-Fi 6 is also available to the 2.4 band as well. And also there are some features in it that are specifically related to enhancing both the indoor experience and also the outdoor experience, so where you potentially have long-range links that are based on Wi-Fi 6, so improving the performance of those. In terms of the two bodies, so IEEE is the organisation that actually writes the standards, so lots of very clever people that actually write how this stuff actually works at a low level and define that. Whereas the WFA, the Wi-Fi Alliance, are actually the body that does the certification, amongst some other things as well. So they're an organisation or a body, essentially volunteers, that actually help to write and define all the testing criteria. So when you buy a Ruckus access point and you buy your iPhone or whatever device it happens to be, that they will actually play and work together. So that's really what the difference between the two are. So IEEE works on using the standard names like 11AX. Wi-Fi Alliance is moving to this new sort of terminology of using numbers for the different types of Wi-Fi technologies. Just at a high level, so I'm going to be talking about a few of these in terms of how they're actually used to improve things in Wi-Fi 6. So just as a sort of high level, I'm not going to go into exactly how the modulations and encoding and so on work, but just a few terms that I'll actually be using. So OFDM is the method of encoding and modulating data onto a carrier signal that's been used since the days of 11G, 11A, and so on. So really since that time, that's what's actually been used to put the raw data onto an RF signal for transmission and then receipt by the client device, or vice versa. OFDMA is a new technique in Wi-Fi 6. So OFDMA itself is a technology that's been around for a long time and used by other types of data transmission, such as LTE. So your cellular data, like 3G and 4G, use OFDMA. So there are some techniques within that that actually vastly improve the capacity of Wi-Fi 6 compared to using OFDM. And the other one is QAM. So QAM is actually a technique that's it basically uses differences in phase and amplitude to actually modulate or encode the signal onto the carrier wave, whether you're using OFDM with it or whatever it happens to be. And again, the more symbols that you use within that, the more data you can transmit. So going from 11AC, where you typically had at best 256 symbols being used, with 11AX, you get up to 1024 symbols. So it's potentially giving you about a 25% throughput improvement, just simply by that increase in symbol numbers. But I'll talk about some of the cons of that as well. So it's not all goodness, unfortunately. So that's really dealing with encoding modulation, some of the terms that I'll be using. And then we've got more dealing with the radio stuff. So hopefully everyone here that's dealing with Wi-Fi, has dealt with Wi-Fi, has an understanding of what a spatial stream is. Anyone heard of spatial stream? Can you hear me at the back still? Can you still hear me at the back? Good, lots of nods. So spatial stream, so in the old days, if you look back to G radios, A radios, it was a single radio in an access point and a client device with a single antenna, and it was basically a serial stream of data between them. When 11N came along, there was this concept that had been used in other radio technologies called spatial streaming. So if I go from a one-stream AP to a two-stream AP, I'm actually sending the data in parallel, and therefore I'm doubling my capacity just by adding that additional radio, my performance. So it's a very simple way of actually significantly improving your performance by adding more spatial streams to your access points and to your clients. The downside of that is that typically your access points will have lots of streams, but your clients won't necessarily have lots of streams. So, like my iPhone 6, iPhone 7s, iPhone 8s, typically single stream devices still. So you don't necessarily get all the raw benefit of having multiple streams, but we'll talk a little bit how they can be used better in the other two topics here. So my mode ties in with the stream, so that is where you're actually multiple in, multiple out, is where you're actually using these multiple streams to simultaneously transmit data between the client and the access point. And then you've got multi-user MIMO, which was introduced into Wave 2 of 11AC. So this is where, for the first time, wireless moved away from being a pure half-duplex technology, where an access point could only communicate with one client at a time. With the advent of multi-user MIMO, an access point could actually communicate with multiple clients at the same time. So that really improved the downlink efficiency, but it was only in the direction from the access point to the client device. But if you had client devices that support multi-user MIMO, you've got a big improvement in efficiency in the downlink direction potentially, because the AP could actually communicate with multiple clients at the same time using different spatial streams. Don't need to go there. So within schools, you should all know this, and obviously this is built across different industries, this slide here, but there are a lot more systems that are connected via Wi-Fi. And of course, it's not just Wi-Fi now as well, we have IoT, so you may have BLE radios as well. You may have Zigbee as well, so you may have Zigbee radios that are used typically for building controls, automation, maybe security and so on as well. But from the Wi-Fi world, there are a lot more devices being connected. So, you know, anyone here who went to Tibet, for example, would have seen that there are a whole load of stands dedicated to, you know, augmented reality, virtual reality as well. I don't know how many schools have actually deployed any of that stuff because, you know, it's obviously pretty expensive. Any schools here using virtual reality, for example, for learning? So one there. And a little bit, yeah. And obviously for things like that, you need great Wi-Fi to do it, of course, because, so at BET, there was an exhibitor that was doing virtual reality in near us. They had a prosumer brand access point, and they were trying to put up a bunch of headsets, and it just didn't work, because in the halls at Excel, it's an aggressive RF environment. So they actually borrowed an R510 from us, and they actually then could get their headsets, their VR headsets to work in that environment. Whereas an ordinary sort of prosumer, I won't mention, you know, Ubiquiti or anyone, but you know, that sort of brand of AP just couldn't cope with the level of interference in that RF environment. But a whole load more stuff, you know, that's being added, and you know, of course, things like, you know, door locks. So it's not just pure client devices like tablets and phones and stuff like that and laptops. It is other stuff that may be managed as part of building. So environmental controls within schools, heating, lighting controls, cordless door locks, security cameras and so on that may be hooked up to Wi-Fi. And of course the number of devices per student are also typically growing, especially when you have halls of residence. So if you have a school where you have halls of residence, then typically you may have to be catering for maybe 5 to 10 devices per student they may use in the room but are Wi-Fi connected. So the number of devices per student are also going up by a lot as well. In terms of speeds and feeds over the years of Wi-Fi, so building from your left to right there, or mirror image here, so you can see how, you know, things have actually improved quite significantly in terms of Wi-Fi speeds from where they were in the early days. Hopefully there's not too many people still running just 11G networks, for example. Hopefully, you know, most people here are on the 11N at least, especially if they're trying to use them for any sort of performance or capacity. But, you know, 11AX or Wi-Fi 6, you know, has this big headline number, but it's promising this really big number. A couple of points there to note is, although it looks a very good number, very big number, but, you know, the kind of considerations there is that that's the physical data link layer, so that's the best speed that could be negotiated between a client that has the equivalent capabilities as your access point and using 160 megahertz wide channels, which is not actually going to be practical in most cases. And it's the phi rate, so typically your actual throughput is going to be, you know, to all intents and purposes, depending on the technology, 50% of that. So, you know, if you've got out of an access point that's 8 streams and 4 streams on the 2.4 gig, if you've got somewhere close to maybe 4 gig out of it, I think you'd be doing very well in terms of real data. But, you know, you'd have to have clients and so on that match to it, and in practical terms, that's really not going to happen. So, you know, big numbers, but you know, it's not something that you're going to really be seeing anytime soon. And I think as part of that as well, so what we're seeing is the shift that Wi-Fi used to be kind of treated as, you know, speeds and feeds. So it was, how fast can this client do? I'll do a performance test on this client. Oh, that's how fast my Wi-Fi is. So very much sort of like comparing it to switch ports. It's, you know, what's my switch port? Is it 1 gig, 10 gig was 100 meg port, whatever it is. What we're seeing though with 11AX is that the focus is moving much more, as I mentioned, to capacity. It's about how many users you can actually sustain and give those users a really good level of performance each. And we'll see how Wi-Fi 6 is actually helping with that. So here we are. So, you know, as I mentioned, a lot of techniques that we'll talk about coming up after this part is about how Wi-Fi 6 is helping to improve RF congested environments, to improve the performance of the clients in there. So it's not about necessarily improving the individual client performance. It's about, if you have a lot of clients connected to your access point, or a number of access points in a high density environment, lots of access points deployed, maybe every classroom, maybe every other classroom and so on. It's about helping to ensure that each client actually has a really good level of throughput and is much better than it used to be in 11AC for each of those clients. It does, however, also as a byproduct provide higher per client throughput, but it is really about the aggregate throughput as opposed to the individual client throughput. There are techniques in there, as we'll see, TWT, to extend client battery life. So that's an important thing in schools, is to actually, for mobile devices, to actually have a much better battery life than you have today without recharges, of having to chuck all the iPads, if you've got iPads, or your netbooks into charging trolleys or whatever it happens to be. Mentioned already, applicable to the 2.4 and the 5 gigahertz band. Obviously backward compatible with all the previous standards, so it is an evolution of all the previous standards. It's not something completely new. So if you do have older clients in there, if it does have to coexist with older access point technologies, then it can do that as well. And the other part of it that's quite often overlooked is that anyone here remember crack, the vulnerability of WPA2? So some of those you may have to patch various systems. On Ruckus we had to have patches for the access points for the crack vulnerability, and there were a couple of other vulnerabilities. So WPA3 was brought out to actually address some of the vulnerabilities, because WPA2 has been around since 2004, so it's a pretty old authentication stroke encryption standard. It's an old encryption code preset. So so that's being updated, and part of AX will actually make that mandatory to use as well, or certain parts of WPA3 mandatory to use. So I'm going to bullet point, I'm going to drill more deeply into some of these, so I'll only cover them at a high level, but these are really the key sort of features and differences and enhancements within Wi-Fi 6 or 11AX, whichever you still prefer to call it. So the first one is this technique of modulation called OFDMA. And really the main thing that you need to know about it, I've got a couple of slides on it, is that it's just much more efficient in utilising the actual channel that the AP is on. And I'll show that in pictures rather than doing it in words. So it's all about improving the network capacity. We've got the introduction of uplink multi-user MIMO. So I mentioned that with 11AC, Wave 2, we had this concept of actually the AP being able to talk to multiple downstream clients at the same time to improve efficiency and deliver data more quickly. With Wi-Fi 6, you get the ability to actually do uplink multi-user MIMO as well. So again, another sort of leap in terms of efficiency for devices that can actually use that. Target wait time is the battery efficiency improvements. I've got a slide on that. I'll talk about that in a bit more detail. 1024-bit QAM, I've kind of mentioned that, so another modulation technique, but I've got a slide on that separately. And long OFDM symbol, so this is just effectively allowing you to put more data at the same time, with having what we call a smaller guard interval between the actual frames of data. So for indoor, it means you can have a shorter guard interval and fewer of them, which means you get to send more data, so it's more efficient. With outdoors, where typically you don't have a lot of antenna diversity, what it actually allows you to do is to still send larger chunks of data, but to have longer guard intervals to actually protect that and make sure it's delivered and that the frames don't overrun each other. So a couple of enhancements there to the symbol length that actually help to improve indoor and outdoor environments. And then fine MAC enhancements. So this is really about, when you look back to the old days of 11B, 11 sort of G, for example, the efficiency between your link speed and what your actual throughput may have been around, the sort of 40% mark. So, 60% of what your data rate was actually being lost in management overhead and just overhead of the format for frames and everything else as well, the modulation and so on. So as Wi-Fi's evolved, the efficiency of it has become, has improved much more. So when you're looking at Wi-Fi 6, you may be looking in the region of something like 55 to 60% efficiency. So if you had a gig link, you may be getting 550 to 600 megabits per second, if you had a gig link, of actual throughput, compared to older technologies where you may have been getting 400 or 450 megabits per second. So you're getting more bang for your buck by improvements to the finer MAC layers there. And the last one is BSS Covering. So this is to do with predominantly high density deployments where access points are actually going to be overlapping in terms of spectrum. So it's a new feature that actually helps that. So where you've got congested networks, where you've got high density deployments, it will actually help out with that. So looking a bit more detail into OFDM and OFDMA. So everyone here, hopefully, well, certainly everyone's familiar with Wi-Fi, knows that access points sit on a channel. So a channel is like a lane of a motorway. So each access point goes on to, or hopefully goes on to a different channel, and that channel is an allocation of frequency or spectrum for that particular AP that the clients in the AP will use to communicate. In OFDM modulation, effectively that whole bit of spectrum is allocated to to the client but is being communicated with. So whether the client's talking to the AP or the AP is talking to the client, that whole part of the spectrum is being used. And it may only need to use a small part of that spectrum. You may have a lot of wastage there. So it's not particularly efficient. So what OFDMA brings to it is that it actually allows the spectrum to be split up, so the tones of the spectrum or the subcarriers to be split up into what's called resource units. And those resource units, interestingly, can be allocated to individual clients or client devices. So it's another way of doing multi-user MIMO. Rather than using multiple spatial streams, it's actually using these different subcarriers, so it's a much more efficient way of doing multi-user MIMO than what using spatial streams is. This is just another way that I sort of put just to try and illustrate that. So when you're using spatial streams using OFDM, it's like you're putting a little bit of data, and especially if it's a small part of data, using a whole lorry to transport that data, and only one client's communicating at a time. So the time taken to deliver all of those little bits of data is X. However, with OFDMA, because you can package that all up into one lorry and send it, the time to send it is much shorter, it's much more efficient because you're able to use the whole load space of that lorry to deliver that cargo, those individual bits of cargo. So it's a lot more efficient for delivery. This slide here is just showing you some of the difference between it. So without, again, getting too much into the technical side, with using spatial streams, for example, you have to have a sounding frame to discover where the client is so that you can actually transmit beamform to it. So that takes an amount of overhead. You don't need that when using OFDMA. It's not necessary to do that. The key one there is the difference between the two. So with OFDMA, it's better for applications that don't require so much data. They're not so data intensive. They're better for sort of lower data rate applications. So VR, for example, might not be an ideal application for OFDMA, depending on what your channel width and so on is. But certainly things like web browsing and so on would be a good candidate for that. So using spatial streams, they actually carry more data because each stream is allocated to an individual client, so it can carry more data. So it's better suited to high throughput applications than OFDMA is. So we're going to go through the rest. I guess the other key number there is, again, depending on things like channel width, you can support a lot more multi-user MIMO clients using OFDMA than you can use spatial streaming as well. So it's a lot more efficient in terms of the number of clients it can support. Looking at QAM, who's familiar with constellation charts for modulation? Okay, so we're getting a bit too deep here then. Is there a slight nod here, maybe? Too deep? Is that a yes, or is that I'm going to sleep? No, it's familiar, yeah. So this is just a way of representing all the available symbols or the number of ways that you can actually code the data onto your carrier, so encode it and modulate it. So 256-bit QAM is what we have in 11AC. And what this is representing on the left one is that in a good RF environment where you've got very low noise, the AP is sending effectively these 256 symbols with data encoded on it, so they're changes in phase and in amplitude. And the receiving client can actually decode all of that because it's a nice clean RF environment. The client is close to it, the client's in the room, it's the same room as the AP, not the other side of a brick wall. So going from 11N to 11AC, for example, you get 33% performance improvement just by going from 64-bit to 256-bit QAM. So big performance, but it requires a good RF environment. What the other two pictures there are representing going towards the right is that as the RF environment gets worse, the client gets further from the AP, it becomes more murky to pick those little targets out. That the client or the AP can't actually tell the slight differences in change of amplitude or phase. They get slightly corrupted, so it has to negotiate down to a lower level of modulation, which affects the client speed. So that looks fairly complex, but when you bring up 1024-bit QAM, this is what you're trying to now decode as a receiver. So there's a lot more symbols that you've got to try and decode, a lot more more small changes in phase or amplitude to be able to decode. So obviously 1024-bit QAM, although it can add 25% performance improvement, it's really a technology that's only going to work when you're fairly close to the AP and you do have good RF environment, not a lot of noise within that RF environment. So target time to wait is just it's a new way. It does really two things. So it's basically a negotiation between the client and the AP in terms of when the client can go to sleep to save battery power. So therefore, it can go longer between charges, as I mentioned. But it's also helping to alleviate the sort of the congestion as well, or the contention within your wireless network, because it's actually starting to work on a proper schedule. So Wi-Fi before this was all pretty random. So the way that it was written did actually work quite well still, you know, with random backoffs and so on. But this is actually starting to add a lot more order to the way that Wi-Fi works. So it helps to, you know, reduce the amount of contention because things are more ordered. They all work on like a triggered period that's been negotiated between the access point and the client itself. So it should save you some battery life. And then we've got BSS Covering. So this is where if you have two access points and they have overlapping RF because you've had to deploy. So in a multi-floor school, for example. So if you have multiple floors in the school, you're typically going to be deploying access points, or your partner is going to be deploying access points in a sort of a W or a diamond shape. But if you've got access points on the ground floor, one on the middle floor, one on the top floor, one on the next floor up and so on, there is going to be, you're going to run out of channels at some point, and some access points are going to sit in the same part of the spectrum. If that happens, if you've got a client like we're showing here, I don't know if you can actually read that, yeah, just about, probably not at the back, but in the middle, the user 2 client there. That client can actually hear an AP, whether it's an AP it wants to talk to or an SSID it wants to talk to. It doesn't, if it hears anything in its part of the spectrum, it's got to wait until those communications have finished. So what BSS Covering actually gives you, is it actually puts like a color tag into the different BSSs, the SSIDs effectively. So it means that you can have overlapping frequency, and if a client is actually trying to talk to a different SSID than one that's actually in the overlapping space, it can actually go ahead and do that. So as soon as its airspace is actually clear from its AP, it can go ahead and talk, even though it's in the same part of the spectrum as a neighboring AP. As long as the BSS colors for those are different, then it can actually go and communicate. So this is, again, reducing contention in the wireless network, and it's also improving the capacity of it quite significantly too. So, you know, that's some of the things that have helped to, you know, make Wi-Fi 6 a lot faster, a lot more efficient than it is today in terms of 11AC. It's not, however, all sort of plain sailing. Of course, I know you're all gagging to get out there and buy your Wi-Fi 6 APs there, so you've got some new stuff to hang up. But there's some considerations. So the first one, you know, we saw that slide that shows you the different speeds and feeds of Wi-Fi networks over here. So you can see, you know, potentially you're going to be able to push easily past a gigabit per second on an access point. So, you know, having a gig port on an access point is you know, going to start becoming something of the past. So you need to potentially look at your switch infrastructure as well. So do you need to have 2.5 or even 5 gig ports on your access switches to actually be able to, you know, deal with the amount of throughput that you're going to get from these access points? So that's one consideration. Another one is your cabling consideration as well. So as part of that follows on, what about the cabling you've got? So, you know, I hope everyone's at least on sort of Cat5 or Cat5e, but not necessarily. You know, old buildings like this may still have some very old cabling that won't support, you know, 2.5 gig E, let alone having Cat6 cabling to support 5 gig E if you need to do that on premium APs, sort of H-stream APs. In terms of how you build your switch network, whether you're using stacking technologies or you're using link aggregation between them, will you need to actually up the speeds and feeds between that connectivity or interconnectivity between switches? Switches to the aggregation layer, switches to the core, whatever you have. What about your internet connection? You're now able to push a lot more traffic over your wireless network. Do you have to look about what your internet feeds are sort of like? Then higher PoE budgets is another consideration as well. So the APs are going to be drawing a lot more power. So with AX technology, most of the APs that are coming out are typically 4 or more spatial streams in them. They require a lot more power. So they're going to require AT at least. In some of them, if you look at an H-stream AP, is going to require BT power, so 60 watts of power from the power source. So another consideration. So looking at your whole network as part of a refresh of you know, Wi-Fi 6 is something that you'll have to consider as, you know, as a potential cost there. The other one, or the last one there, of course, is your client devices. So it's all well and good having this great new shiny AP that's Wi-Fi 6 capable, but if you don't look at upgrading your clients, then of course, you know, the speeds that you actually get out of it are only going to be as good as what your previous technology is. So you have to look at the client side as well. So it's, you know, it's not a cheap process to actually move on. And 11AC is going to be around for a long time still. So, you know, if anyone's considering buying, you know, or refreshing their network now, 11AC is going to be, you know, viable as a technology in terms of performance capacity in education for, you know, a good 3 to 5 years yet. So it's not like AX is here, that's what I've got to buy. you know, AC is still a very viable technology. So this is just a few of the timelines. So looking from the perspective of the IEEE, who write the standards, the WFA, who write the certification plans for it, and then also a little bit the blueies from the device manufacturers, both, you know, from an AP perspective and from a client device perspective. So as we can see here, if you look at the orange, the IEEE, the actual standard for AX, so they call it AX, of course the Wi-Fi Alliance call it Wi-Fi 6, 11AX has not been ratified yet. It's past its final draft stage, but it's not looking until probably next May, but it'll actually be a ratified standard. So anything you buy now, effectively, you know, is a pre-standard draft, effectively. So you know, it's a little bit of a strange situation that the Wi-Fi Alliance are actually starting their certification plan before the standard is actually ratified. It's normally the other way around is the norm, but the standard is ratified, and then the Wi-Fi Alliance actually does their testing plans. This has actually happened kind of a little bit out of step. But nonetheless, the Wi-Fi Alliance testing plan should be available already for about August timeframe is when they're planning on launching those. So today you can't buy a Wi-Fi 6 certified device. They don't exist. So you know, if you look at some of those devices today, like the Samsung S10, it's Wi-Fi 6. It's a Wi-Fi 6 device. It is AX capable, but it's not certified today. The certification doesn't actually exist today. So just be a little bit aware. You know, you are, if you're looking at AX again, you're a little bit on the bleeding edge, just, you know, as you have been with some other wireless technologies. So it's still, you know, playing them out of catch up in terms of delivering on the certification plan there. The interesting one there is that the from what we've seen, it looks like Apple are going to be announcing an AX-capable iPhone. So the next iPhone, which normally they make their announcement in September, is probably going to be AX-capable. And clearly, you know, Apple still own a fairly large, large share of the handset market. So if they do, and people start upgrading, then the adoption of AX will be that much quicker. The other bit of bad news there is that just like with 11AC, for those of you who are kind of familiar, it's delivered in 2 waves. AX is also going to be delivered in 2 waves. So when you buy an AX AP this year, doesn't mean it's going to have all the functionality that will be available in a couple of years' time potentially. So, you know, it is a bit of pain, and this is nothing to do with the IEEE who write the standards. This is the way that WFA introduce it and do the certifications. So, you know, wave 1, which the certifications will actually start August timeframe, hopefully. Wave 2 will be potentially 18 to 24 months after that certification. This is in terms of Wi-Fi 6, 11AX functionality. This looks our view on what the split is between that functionality today. You know, there might still be little changes. Some things that look like they're going to be in Wave 2 may come out earlier. So in Wave 1, we're going to be supporting downlink and uplink multi-user MIMO using FDMA. We're going to be supporting downlink spatial stream multi-user MIMO, which we've already got in 11AC Wave 2, and target wait time for improved battery efficiency is also going to be in Wave 1. Then in Wave 2, that's when you start to get the uplink spatial multi-user MIMO, so OFDMA is going to be in Wave 1, but spatial based will be in Wave 2. You've got that BSS Covering, which, you know, looks like a nice feature for high density networks. So the actual raw sort of the raw sort of ability to do that, or capability to do that, is actually available in Wave 1, but the functionality that sits on top of it won't be available. So one of the notes I put there is to be a little bit aware of marketing. You know, if you go and look at some vendors that say that, you know, they've released a Wave 1 AP and they says it supports BSS Covering. Well, it supports BSS Covering at a raw level, but you can't actually use it. So, you know, have to be a little bit careful about what marketing might come out around that. 160 megahertz channelization. Remember, to get that big 9.6 gigabits per second speed, you need to use 160 megahertz channelization. So that's not really come up until, you know, till Wave 2. So not that you can really use 160 megahertz wide channels anyway, so who cares? The interesting one is allocation of some new spectrum for Wi-Fi. So that's long overdue. So 2.4 gigahertz we know is pretty congested. 5 gigahertz is starting to become more congested as it's more used. So we're looking at opening up more spectrum, or the regulators are looking at opening more spectrum. So there's some spectrum in the 6 gigahertz space in the US. They're looking in Europe. They're looking to harmonise some spectrum in 6 gigahertz space as well, a smaller chunk of spectrum. As I understand it, in the UK, that spectrum is not available. So Ofcom are actually looking to see what other bit of spectrum they can actually allocate to Wi-Fi to give it some more frequency to work with to improve performance. But that's definitely sort of overdue and long needed, is to actually have some more spectrum allocated to Wi-Fi. WPA3, which I mentioned at the start there, so just a few notes on this. As I said, it's going to be eventually the successor of WPA2, so it is more secure. It's about preventing things like dictionary attacks, things like the crack attack, for example, there. Things like being able to sort of full client devices that are doing enterprise 802.1x authentication, fool them into using a different authentication server instead of the one they're meant to be using. So effectively, kind of like using a Trojan type of authentication service for .1x enterprise. Adoption of 802.11, which is protected management frames. So today all the management frames are unprotected. So again, that's another vulnerability, because people can actually capture management frames over the air and start to learn a lot about your network and then try and use that to actually hack your wireless network. So encryption of management frames is something that's going to be enforced. It's been available for some time, but it's not been enforced. Higher bit level of cryptography, so encryption level as well is part of that. And then the other interesting one, the last one there, is the ability for the AP and the client to be able to negotiate an encrypted session. So this is really aimed at open type of networks that you have today, so sort of public guest networks and so on, that typically you don't bother encrypting because you don't want to bother giving your guest visitors, for example, you don't want to give them a pre-shared key to use, it's too much hassle and so on, and managing that, whatever it is. So this actually allows the client device to negotiate an encrypted session between the device and the AP itself. So it's helping to make open networks more secure than you have today. So any questions on Wi-Fi 6 11AX before I just do my little marketing piece here? Stunned silence. Ben, I was told you were going to ask lots of questions. No? Okay. No? Okay, I'll carry on then. Well, we might go down the pub earlier then. Okay. Right, so Ruckus was actually the first company to release a high-end premium AX AP. So back in, I think it's towards the end of Q3 of last year. So it's an 8-stream on the 5 gigahertz and 4-stream on the 2.4 gigahertz. So 12 spatial streams in total. So it's a high-end, expensive, big, heavy AP. Really designed at those ultra high density deployments like stadiums and so on there, where you have a lot of clients on the AP. So it supports up to 1,000 clients per AP. So it is really about ultra high density. Not really something I think you'd be putting into schools in general. But what we are doing over the remainder of this year, so as the Wi-Fi Alliance certification plan becomes available, we'll be releasing the R750. So that's like still a premium AP, but it's slightly down spec. So it's 4 spatial streams on both radios. So not quite as high spec as the R730 that we've already introduced. Then later on, towards the end of the year, we'll have the R650. So that will be a premium mid-range AXAP. As I mentioned, it's all about capacity. So there are no plans currently for like a 2-stream AXAP. It will probably come in time, but really, given that AX is targeted at high capacity, high density networks, we're concentrating on the sort of the premium mid-market and above that. But there's still places for something like a 650 or potentially 750 within education. There's still places where you may have clients that have the same sort of performance capabilities, so maybe new MacBook Pros and so on, or in higher density environments, so somewhere like in the cafeterias, refectories and so on, where you'll have a much higher number of clients per AP, or potentially again within the sort of the boarding houses and so on, where you may have a high number of client devices. So that's where you may potentially fit these APs, but in general I'm not seeing that they're going to add a lot more over a typical deployment of 11AC APs today within a classroom environment. And also to complement that, also an outdoor AXAP as well later this year. So that's all I've got to say. A question? Oh, good.
Ruckus, so what switches would you have to change in your IX range? Is that a complete new structure?
So we, some time ago, we introduced at the low end, the 7150 product family. So that's our entry level that competes with the entry level HPs, for example. We introduced a Z series in there. So the Z series has got multi-gig capability. It has 16 2.5 gig E ports. So the 750 or the 650 AP there, which has 2.5 gig E ports, you can actually use those with the 7150 Z series, and it supplies PoE, enhanced PoE for that as well. So that's potentially an access switch. Or we have other switches like the 7650 that was also introduced, but that's sitting much higher up the product family. That said, keep your eyes out for a new announcement. We are introducing, by the end of this quarter, a new small form factor AP. So an 8-port AP that will support 2.5, 5 gig, 10 gig ports. It will support BT, AT, power supply, and it's specifically designed for those, for those deployments where most of your APs are just gig connected. They require AF or AT power, but you've got to put into your refractory and some other places, you've got a couple of R750s or R650s you want to put in, and you need 2.5 gig E connectivity, maybe you need BT power. It's a small form factor 8-port switch that allows you, rather than having to put in a 24-port very expensive switch, something that is more cost effective to run those APs. So keep your eye out for those. Any questions? Good. No? No?
Not data protection reasons. One of the things that always happens whenever any new access point comes out is it's faster, it's better, you can have more devices connected. This, with AX, there's still some things out there that say this is going to be so much better, you can have more devices. But it's not clear to folk about the issues around the noise. And this is going to be, the location, the nearness of devices to the access points. That's still going to be a problem. We're not going to have additional power through these devices so that they can actually be fewer and further apart.
No, so I didn't cover all the points on the little chart I had, but the last point on there was that OFDMA actually does work better across all ranges, and especially at longer distance. So you will see some benefits in terms of kind of extended range from it compared to 11AC, for example, and OFDM modulation. So how much that is difficult to know, but so certainly some of the techniques like high rates of QAM modulation. Yeah, you've got to be even closer to the AP than you were previously for that to work. But on the flip side, generally higher performance, capacity actually allows you to get better performance further away from the AP than you would have had before.
So there is a possible cost-benefit analysis of moving up to the AX because it could be fewer access points.
That's correct, yeah.
And even though it's a slightly higher price bracket, it may be cheaper overall.
Yeah, and that obviously, and it really depends. You have a building like this has generally fairly thick walls and so on, so the RF penetration is not as good as maybe some other forms. So certainly new builds tend to have high attenuating sort of films and so on in the wall, so they looks like a stud wall, but actually from an RF perspective, it's like a big thick concrete wall. But if you look at typical schools that were built from the 60s to the 80s, their walls are pretty thin from an RF perspective. So definitely the mantra there is from an RF, from a Ruckus perspective is fewer APs because the APs get better coverage than our competitors. So you can get away with an AP every other classroom, for example. And the savings, so along those same lines, if you put in fewer APs, it's not that you're just spending less on the APs, you're obviously spending less on the cabling, you're spending less on the switch ports, you're spending less on actually powering those switches, so there is, and support and so on. So, it kind of has a knock-on that if you're reducing the number of APs, you're actually reducing the cost, along that whole sort of network chain.
So the crux of it comes down to that initial survey?
Yes.
So doing it without having a survey probably isn't a good idea.
No, and there's different ways, obviously, of doing a survey. So, partners will typically be using, tools that are designed for doing proper RF surveys. AirCal or AirMagnet, for example, in conjunction with a spectrum analyzer. You can obviously get sort of freely available tools that are sort of more or less finger in the air, and you can spin it up and see, well, if I put the AP in that room, what is my signal in this room? So, you can be scientific or as kind of not scientific. One in there, one in there. You happens. But yes, the better your survey, the better or more accurate results will be, because if you particularly use a fairly simple tool for checking a few points around the network as to what the propagation is, you're probably going to end up with some dead spots somewhere. Will someone at the back put their hand up? No? No? Okay.
Oh,
Right, we're done. Thank you very much for your time.
Thank you.